If sine of alpha equals 12 over 13, where the measure of the angle alpha is between 0 and pi over 2 radians, and cosine of beta equals 20 over 29, where the measure of angle beta is between 3 pi over 2 radians and 2 radians, find the exact values of the following: sine of alpha plus beta, cosine of alpha minus beta, and tangent of alpha minus beta. So the first step to this problem is finding the missing values. The missing values are cosine of alpha and sine of beta. They've already given us the sine of alpha, but we need to find the cosine. And they've already given us the cosine of beta, but we need to find the sine of beta. To do this, I'm going to use the equation cosine squared alpha plus sine squared alpha equals 1. So we're trying to find this, but we already know this. We're going to substitute cosine squared alpha plus sine of alpha is 12 over 13. So 12 over 13 squared equals 1. Rearranging the equation to equal cosine squared of alpha equals 1 minus 12 over 13 squared. Solving this in the calculator, for the value of cosine squared alpha, I get 25 over 169. I'm going to square root both sides to get rid of this squared over here. And my final answer for cosine of alpha is plus or minus 5 over 13. Looking back to the question, we see that they've given us the information that alpha is between 0 and pi over 2 radians, meaning that it's in the first quadrant, which means that this is going to be positive. So we have our missing part to the equation for alpha. Moving on to beta, I'm going to use the same equation over here. Cosine squared of beta plus sine squared beta equals 1. We already know this. 20 over 29 squared plus sine squared beta equals 1. Rearranging the equation to equal sine squared beta, I get 1 minus 20 over 29 squared. Putting this into the calculator, I get 441 over 841. Square root both sides to get rid of this squared. And I get sine of beta is equal to plus or minus 21 over 29. In the question, they tell us that beta is between 3 pi over 2 radians and 2 pi radians, meaning that beta is in the fourth quadrant, and all y values in the fourth quadrant are negative. So our final value for cosine of beta is negative 21 over 29. Or sine beta equals that, and cosine alpha equals that. The first part of the question on the previous page was sine of alpha plus beta. To figure this out, I'm going to use the equation sine of alpha plus beta equals the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. Substituting these values into this equation, I get sine of alpha equals 12 over 13 times cosine of beta is 20 over 29 plus cosine of alpha, which is 5 over 13, and sine of beta, which is negative 21 over 29, multiplying these, I get 240 over 377 plus a negative 105 over 377. Simplify this and I get 135 over 377. This is how to write sine of alpha plus beta in its exact form. So the second part of the original question was cosine of alpha minus beta. To solve this, I'm going to use the equation. Cosine of alpha minus beta is equal to the cosine of alpha times the cosine of beta plus sine of alpha times sine of beta. I'm going to substitute these values into this equation. Cosine of alpha equals 5 over 13. Cosine of beta equals 20 over 29. Plus sine of alpha equals 12 over 13. Sine of beta equals negative 21 over 29. Multiplying these, I get 100 over 377. So multiply these two, 100 over 377 plus negative 252 over 377. Simplifying this, our final answer is negative 152 over 377. So this is how you write the cosine of alpha minus beta in its exact form. The third part of the original question was find the tangent of alpha minus beta. To find this, I'm going to use the equation tangent of alpha minus beta is equal to tangent of alpha minus tangent of beta divided by 1 plus tangent of alpha times tangent of beta. So to find tangent of alpha and tangent of beta, we have to remember that tangent of anything equals its sine over its cosine. So to find tangent of alpha, we take sine alpha and divide it by cosine alpha. Sine alpha is 12 over 13, divided by cosine alpha is 5 over 13. I'm going to multiply 12 over 13 by 5/13 reciprocal. Cancel these. And our final answer for tangent of alpha is 12 over 5. Finding tangent of beta, we take the sine of beta and divide it by the cosine of beta. Sine of beta is negative 21 over 29. Cosine of beta is 20 over 29. Multiply by its reciprocal, negative 21 over 29 times 29 over 20. Cancel these two, and our final answer for tangent of beta is negative 21 over 20. So we have found tangent of alpha and tangent of beta. So I'm just going to call this the numerator, n for numerator, and this d for denominator, and solve this in two parts. For the numerator, we have tangent of alpha minus tangent of beta. So we have 12 over 5 from here minus negative 21 over 20. We get 12 over 5 plus 21 over 20. And putting it into your calculator, you get 69 over 20 as your final answer for what the numerator value will be. So this is what this whole value is. The denominator is 1 plus tangent of alpha times tangent of beta. So tangent of alpha is 12 over 5 times tangent of beta is negative 21 over 20. I get 1 plus negative 63 over 25. Which equals to negative 38 over 25. So this is our final answer for what the denominator value is. This whole denominator is equal to this. Bringing these two back to that equation and plugging these values in, we get tan of alpha minus beta equals the numerator, which is 69 over 20, divided by the denominator, which is negative 38 over 25. You can multiply by its reciprocal, 69 over 20 multiplied by 25 over negative 38. Can simplify these or put it into your calculator, but the final answer for tangent of alpha minus beta is negative 345 over 152.